Hi, welcome. I'm Dr. Jayanti from Experiential Math Solutions. In this video, we will talk about three more mathematicians. One is Eratosthenes and his famous sieve method to identify prime numbers. When children know counting from 1 to 100 and basic tables, multiplication tables from 2, 3, 5 and 7, we can introduce this to identify prime numbers from 1 to 100 by eliminating the composite numbers. Talking about Eratosthenes, he was a famous Greek mathematician who lived nearly 200 years before the birth of Jesus Christ. He invented this ingenious sieve method to identify prime numbers. The method is as follows. Cross out 1 as 1 is not a prime number. 1 is neither prime nor composite. Circle 2, the smallest, the only even prime number. Then cross out all the multiples of 2. Similarly, circle 3, the next prime number, and cross out all the multiples of 3. Students might have crossed out earlier some of the multiples of 3 like 6, 12 as they are also multiples of 2. The next 4 is already crossed out, so the next one is 5. Circle 5, which is the next prime number. Then cross out the multiples of 5. 6 is already crossed out. Circle 7, the next prime number, and cross out the multiples of 7. Now, circle every number that are not crossed out. You can tell the students that there will be 25 prime numbers from 1 to 100. So if they have made any mistakes, they can check it which one they have crossed out wrongly. When we talk about patterns, we cannot forget Ramanujan. Ramanujan's fascination for numbers made him discover many patterns. We can introduce some simple discoveries of Ramanujan, like this one, 1 times 9 plus 1 is 10. Then 12 times 9, 108 plus 2 is 110. 123 times 9 plus 3 is 1110. Now we can ask the students to identify some, look at the patterns. Now 1, 2, 3 times 9 plus 3 is equal to 3 ones followed by 0. Now you can ask them to continue the pattern, and we can ask them how long you can continue this pattern, when it will stop, and why it stops. These kind of questions will make students think more instead of just following the pattern. Similarly, another one is 1 times 8 plus 1 is 9. 12 times 8 is 96 plus 2 is 98. 123 times 8 plus 3 is 987. Now students should again look at the pattern. If they cannot, you help them to follow the pattern. Look at the pattern. 1, 2, 3 times 8 plus 3. They should not memorize anything. So you can see that 9, 98, 987. So they can see that 987, 3 digits. Now you should have 4 digits. But the first one should be 9, 8, 7, then followed by 6. Again, you can ask them how far they can continue the pattern and when it will why it stops. The next pattern we can introduce is 1 times 9 1. They should know some multiplication. So again, ask them to look at the pattern. Now 3 times 9 27, then 3 27. So fourth one they should not multiply. They should know that it should come 1 2, then what it should be 3, 7 should be reduced to 6, 3 should be increased by 1, 2 to 3, so 3 to 4, like that they should look at the pattern and do it. Then the next one is 1 times 1 is 1, but 11 times 11 is 121. Now 3 ones times 111 times 111 is equal to 1 2 3 2 1. So it goes up to 3. So when you have 1 1 1 1 times 1 1 1 1, it should be 1 2 3 4 3 2 1. Then we can ask them the other way also. If they are from higher class, what will be? Don't ask straight away the multiplication. We can say what will be the root of 1 2 3 4 5 4 3 2 1. It looks like very overwhelming, but when they know the pattern, they can identify it very easily. But again, ask them when it will stop and why it stops. Another one I want to share. Now this time we are not going to give the whole pattern. We are going to ask them, because it will not always start from 1, 2 or 3 or 9. So it may start the pattern from in the middle. Like for example here, 9 times 9 plus something is equal to 88. So 81 plus 7 is 88. But in the next pattern it comes 888. So 98 times 9 plus what is 888? Let them find out. Let them continue the pattern and check how far it goes. If you want to learn more about patterns, you can join our course Experiential Math Content Creator and learn more about patterns and how to introduce patterns in your classrooms. It will be interesting for students to learn about the contribution of Sir Isaac Newton in the field of mathematics. When students have mastered fractions, we can introduce this. Newton's method to find the sum of your series. Maybe grade 6, 7, 8 will be suitable. So 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, it goes on up to 1 over 99 times 100. What is the sum of this series? Though this question looks like a very difficult one, we can ask the students to simplify the problem first. For example, 1 over 1 over 2 is half. 1 over 1 times 2 plus 1 over 2 times 3 is equal to half plus 1 over 6, which is 4 over 6, which can be simplified as 2 over 3. Similarly, the sum of first 3 terms is equal to 3 over 4. Now looking at the pattern, we should ask the students to guess the sum of the series. Students can follow the pattern and identify the sum as 99 over 100. Now we can challenge them. What is the sum of this series 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus 1 over 7 times 9 plus 1 over 9 times 11. Students may guess it wrong. They may think of the previous pattern. Now again, advise them to check the pattern first, at least 3. 1 over 1 times 3 is 1 over 3. Sum of the first two terms is 1 over 3 plus 1 over 15, which is 6 over 15, which can be reduced as 2 over 5. The sum of the first three terms is 1 over 3 plus 1 over 15 plus 1 over 35, which is equal to 2 over 5 plus 1 over 35, which can be simplified as 3 over 7. Now we can ask the students to find the pattern. Students might have guessed that the sum of the first three terms is equal to 5 over 7. As I said, remembering the pattern that they found in the previous question. But when we ask them to simplify it, they will find it's different. Now, how to find the sum of first 5 terms? Once they find this, we can ask them to find sum of first 50 terms. If they are of higher class, we can ask them to find the sum of first n terms. Ask them to generalize the result. With that note, I'm signing off. This is Dr. Jayanti from Experiential Math Solutions. Stay healthy and we will get back to you soon. Thank you. Bye for now.